G'day everyone, it's Glen Morris from the Smart Energy Lab filling in yet again for DJ Glenmo. He did lend me the hat and he did lend me the shirt. But it's good old me. I'm going to do something kind of interesting today and different, which is I'm going to give you a tour of the Smart Energy Lab. So we're going to do a bit of a walk and talk about how this lab functions, some of the gear here, a bit something for everything. You might be into making YouTubes, you might be into cameras and video tools, or you might just be interested in the tech. So it's going to be a bit tricky. I'm going to try and do this with a couple of different devices. So trying to do a continuous recording so you guys can see the stream. And I'm getting my little handheld camera set up and see if the battery's good. Yes, it is. And off we go. So it's recording. I have to do the little intro. So welcome everyone to Toolbox Tech Talk. It's great to have you here again on a Sunday, live from the Smart Energy Lab. And as I mentioned, DJ Glenmo couldn't make it again. He's a bit slack lately, so me, Glen Morris, is filling in, and as a special feature for today, taking you on a bit of a tour around the Smart Energy Lab. Anyway, let's get started. So, whoa, let's see how this goes. I gotta get my little camera thing going here. There we go. So what you're looking at here is the studio, and the lighting will vary as I move around. The studio is where I film my unboxing videos and some of my training content. So it's kind of set up. It's got a bit of a museum behind me of systems. In fact, you might see there's a lot of blue. Just love the color blue as a background. So well done, Victron, for choosing the right color. And in the corner here, we've got one of the newer systems here. And I know it's a bit dark. I probably should turn some more lights on. But what we've got there is a Selectronic SP Pro. They're SPMC 482, which is a 7.5 kilowatt continuous with an incredible crest factor. So it can do up to 18 kilowatts for like a few seconds. And it's been painted gold. That was done by Selectronic to help celebrate our co-op's 50 years of renewable energy. And so it's a special, we call it the Goldilocks edition. Probably you'll never see another one like it. And to kind of complement it, the wonderful people at Power Plus Energy produced a set of gold batteries. These are the Eco 4847Ps, so 4.7 kilowatt hours of storage. There's basically 40 kilowatt hours in this stack here, and it's connected to the SP Pro that you just saw above. So that's powering this whole studio. So all the lights, computers, etc. Air conditioning, well, actually, to tell you the truth, we haven't switched the air conditioning over to that circuit yet, but we will soon. And in the back here, you might see there's a charge controller from the amazing Australian OG of MPPTs. Yep, AERL. AERL produced the first commercially available MPPTs in the world. They actually owned the global patent till like about 2008, but no one really took notice of it, unfortunately. So yeah, that was a bit sad. So hats off to a great Australian company who make some of the most efficient, I think they held the world record, if you remember, for the most efficient MPPT. So that's pretty cool. Now, the filming side of things, it's pretty much a one-man band here at the Smart Energy Lab. So all the cameras and all the lighting and all the equipment can be controlled either manually or automatically for one person. So I basically run around and set up all these cameras and just turn them on. Got one with a slider over here. I don't know if you can see that down there. It kind of adds a bit of interest because it moves the camera automatically, and that gives just a little bit more drama to what's otherwise a static image. This is our sound cart, so we're all sound devices shop here. So sound devices, MixPre 3 Mark II, beautiful 32-bit float recorder, 3-channel, and some of these lovely Deity transmitter microphones with really good lavs on them. all that comes in really handy when I'm doing interviews with clients. Now, speaking of clients, from time to time, they bring an entourage. Don't you always want to bring an entourage with you? And so we have the green room here at the back, so they can actually watch the development in front of the cameras. There's even a monitoring screen here, so they can see what the cameras see, and so they can chill, have their coffee or other beverage, and watch the interview. Yeah. You might see little snippets of equipment as we scan around too, because we test lots of stuff, and sometimes we like it so much we just keep it there. So here we've got our Alpha ESS, the Smile G3 from memory. I think that's the name of it, and it's powering part of this studio, the rear. Let's call it the green room. Yeah, and of course every good shop's got to have its coffee machine. But unfortunately, this coffee machine is playing up a little bit, so I'm just got to get the compressor fixed on it. That's pretty cool. So some of this stuff is currently offline. So we do quite a bit of testing, and from time to time we have to move equipment to test something else. But this one will certainly come back into service. It's the GoodWe SPB 5000 5 kilowatt AC coupled inverter. So not solar connected to it, just AC in and AC backup. And it was paired with a couple of these really interesting looking lithium-ion batteries, lithium titanate. If you don't know about LTO, it's considered the safest lithium, but it's heavy and it's somewhat expensive, but it makes for really interesting designs. So these are from a company called Zenergy, and these are their Eon batteries. I think they're around 2.9 kilowatt hours per pole, and they're a post or column or battery module, and they're a nominal 52 volt lithium batteries. So they'll work with most lead acid compatible inverters as well, because they're self-managed. Okay, so we're coming into, I call this T1, because T1 is T for training. This is where 10 years ago I first started running training courses for students. I'll just pan you around here so you can see it a bit better. So students would often build systems here in the lab, and some of them were built so well, we just have kept them ever since. So this is a AC and DC coupled system. It's got the now legendary OG Fronius Galvo, so one of the last galvanically isolated inverters that was on the market from Fronius. It's got, and that's AC coupled to a Victron battery, which I'll show, Victron inverter. Then we've got a DC coupling. This is the Victron MPPT 150/60, so direct charging of these batteries. And these batteries were quite a sort of known issue in the early days in Australia of lithium. Simplify, it's an American company. I haven't seen them in the market here lately, but maybe they still are. So they Simplify, if you haven't heard of this company, its origins are in the film industry, making location power. So reliability was the most important thing, because the lights must stay on when you're filming. And all of this is connected via the wonderful Links system from Victron. I just love it, with a smart shunt, power distributor, and a power in device. I'm saying OG a lot, but it is rather one of the early color controller GXs. So this is a beautiful thing for customers to monitor their system. And we've got a 5,000 watt Quattro, Victron Quattro, which is what is the grid forming system in this. So this is effectively, I like to say, an off-grid system that one of my students, Go Reese, built some years ago, and we just love it. On this side of the room is kind of the maker space. So if I can scroll down a bit there. So we've got a bunch of 3D printers. Doesn't everyone use them these days? They just come in so handy. I've got my electronics bench. It's a bit messy at the moment, where little projects happen, microcontrollers and Raspberry Pis and little smart devices. The Cheedy, I really love the Cheedy 3D printer. It's got a big capacity. It's got a heated chamber, so it can print with a high temperature nozzle here. So some really interesting filaments. So there you go. And up the top here, if you're a bit geeky, is the data center. So we've got something like, any one time, 160, 170 devices on our network. This is basically a satellite data center up here. The main one is elsewhere, where we've got our router and our dual WAN connection, both Skylink and 4G via Optus. And up here is the RAIDs. So we've got, I think, 16 terabytes there of RAID, backing up RAID 5, all of the files from my videos. So, and under the bench here is more unboxing projects to come. You probably can't see it very well, but down there is a bunch of more unboxings. There's always more stuff turning up here at the lab. Okay, so let's go outside of the building. We're in what I call the studio, even though it's got lots of stuff going on there. Things are a little bit kind of old-fashioned here. This is an old carpentry shed, so it doesn't quite look as swish as a modern shed. But I walked right past another, oh my God, I'm going to say it, another OG. This is the Selectronic 120 volt, 7.5 kilowatt inverter. So 120 volt isn't a very common battery voltage anymore, but Selectronic pioneered it for their high-powered inverters and for combinations of those, so that you could minimize your cable size. You know, when you start to get up to high power levels, you know, say 100 kilowatts, you're going to have some very fat DC cables at 48 volts. Inside here, the cabinet down below is the Power Plus Energy 120 volt. It's one of those models that started with an O and followed by a G as well. I don't think they still make the 120 volts, but there they are. So into this cabinet, there's 3.3 kilowatt modules. Yeah, some really old stuff here. Well, not really old, but I've had this for a long time, the Alpha ESS all-in-one. This was kind of an interesting concept, which is a 5 kilowatt hybrid inverter with a inbuilt small 2.6 kilowatt hour battery module just in the bottom here. And so it's kind of like a starter kit to get you going, but you can add more battery modules beneath or next to it to increase its capacity. So that's an Alpha ESS all-in-one unit, pretty nice. Now we're really going down the memory lane here. This is a Power One, an Italian company who were early in the Australian market, quite popular, sort of around the 2007 to 10, I suppose. This is the skinniest, this is a 3.6 kilowatt inverter, dual MPPT, I think, from memory, maybe. Look how skinny it is. It's probably about 50 mils thick. And I actually installed one of these in a location where nothing else would fit because there was a door that had to open across it. Not ideal, but yeah, it worked. This is a little plan of our system here. At any one time, what's connected to what. It gets a bit crazy, so you know sometimes we've got like 20 different inverters on the microgrid that we're testing. So it's a dynamic whiteboard. It also shows where some of the installations are on homes. So here, the Smart Energy Lab is on an off-grid community called Muramura Co-op, and we've got about 30 homes here. In this little cluster of houses here, around the Smart Energy Lab, or slightly north of it, are 7 homes. And so the microgrid actually supplies power to those 7 homes. Well, I think it's time to go and check out the big boys and girls here, the microgrid system and its sister. So these are buildings that were already here. They're actually old carport. This is an old carport. So once again, not the flashiest installation that you've ever seen, but some of the flashiest equipment, if I can get out of the sun, is in here. So we've got, once again, a whole bunch of Selectronic SP Pros. Selectronic have been a fantastic supporter of the Smart Energy Lab going back over 10 years. They actually provided initially for training just one little 5 kilowatt SP Pro. Then they said, oh, maybe you should do 3-phase Glen. So they provided 5 kilowatts. And then they said, oh, we've just developed power chain. We'll run it over you. Okay, great, thanks. So then they provided another 3, so there's 6 SP Pros here, connected 2 per phase. And then they went, oh, they're only 5 kilowatt units, maybe you should have 7.5. So the wonderful people at Selectronic took back all the 5s, reconditioned them and sold them off as lightly used, and then put in 6 of these 7.5 kilowatt SP Pros. Remember, these can do a massive overload. The crest factor, I think it's nearly 3, which means it can sort of momentarily surge to just a bit over 3, 18 kilowatts on a 7.5. It's not quite over 3, 2 point something crest factor. The system is backed up with a battery pack, once again from Power Plus Energy. These are their Life 4838P, so 3.8 kilowatt hours each. There's 40 of them here, giving me, I think, 152 kilowatt hours connected to the SP Pro power chain. These are kind of a special version of their battery because they've put in their extra monitoring board, and so up the top, which is a bit hard to see, is their monitoring equipment, which is connected to their cloud. So they're actually testing these in the wild, and they do get worked. They would often cycle 80% every day, particularly in wintertime. So they do a lot of cycling. So this is what we call our grid forming system. It creates the three-phase grid to which all the other systems synchronize with. So it's pretty important that this is the most stable and reliable thing you can build, because you don't want your grid forming system falling over, because then all of your clients, all of your grid following systems will isolate. So you don't have a microgrid anymore. Down here is, this is sort of a bit of a loading dock too. So some more equipment. Most stuff you see that comes in here is actually for videos. So we're making some videos for Fox ESS. I'll tell you more about them in a minute. So this is another video with a different inverter hybrid. We've just installed this one, which I'll show you in a sec. It's just on the other side of this wall. It's the 8 kilowatt three-phase hybrid with an enormous battery stack. All right, let me show you. I'm excited. Wow, it is so sunny. You can probably just see me here. See if I can get in a bit of light. So what you're looking at behind me is what we've just installed. So this is the Fox ESS, the H3 8 kilowatt three-phase hybrid. They come in a range of sizes. There's just 3. I think they go up to maybe 15 from memory in this form factor. But Fox have a huge range of inverters. So check them out if you're interested in any of their products. I've been testing Fox ESS inverters for a long time. I've had quite a few of their versions through my lab, and they've always impressed. Quality and design is really, really fantastic. But, you know, why am I super excited about this? Well, it's a bit about the change in footprint. Now, let me show you. I'm just using a few inverters here. So this is the, oh my God, I'm going to say it again, the OG Fox all-in-one. There's a lot of OGs go on here because often I do get the first version. I've had a few inverters where the serial number's like 003. You just know you're early in the production cycle. But this one is a all-in-one system that Fox released a few years ago, and it's got a 5 kilowatt hybrid inverter built in. It's got 4 2.5 kilowatt hour battery modules, so it's 10 kilowatt hours total in a complete case with a screen on this side around here, and then all your connections are behind a cover, which is really nice in the back here. So I always like it when you can hide all your cables. So yeah, pretty nice unit. But just in terms of how size has changed, this unit, which is basically the size of me, is only 10 kilowatt hours of storage. Now, one of the early developers of the stackable battery was BYD. And no, it's real sunny now, but if I kind of get you in the right spot. So these are the high voltage BYDs, the HVMs, and that stack there is 4 of their battery modules, which gives a total of, I think, 11 kilowatt hours of storage. Okay, so down the end there, that was 10. This one's 11, but something with almost the same footprint, the Fox ESS, with the EQ 4800 batteries, that's 41 kilowatt hours. Yeah, that's more than 3 times the amount of storage that the, now rather older BYD has. Now, I'm not saying anything about the quality of either of those, but that statement, it's just footprint. It's amazing how the density of energy storage has improved. So yeah, really impressed with the Fox ESS, their EQ batteries. So these are, they come in a range of capacities too. I think 2.9, a 3 something and a 4.8 kilowatt hour, and you can stack them. And here we've got 9 of them stacked, and that really it's only 1.3 meters high. Amazing. So you can more or less design a system with a very precise capacity because of the modularity of these stackable batteries. So there you go. Well, I whooshed past a couple of things, and you probably saw me as I was whooshing through, and sorry for making it dizzy, the Victron inverters here. So this is a 3-phase system made up of 3 multi-plus 2 Victron inverters. Victron, these are AC in and AC out. In fact, they've got 2 AC outs. They don't have any MPPTs built in because Victron make separate MPPT devices. We haven't got one on the wall at the moment. We had a little explosive moment with it, so we're going to have to replace that one. But connected to it is something really interesting, is these supercapacitors from West. So if I can get you down a little bit lower. Yeah, and we come down. So these here are, I think it's 3.4 kilowatt hour, nominal 48 volt supercapacitors from a South African company called West. It stands for their longer name. I think it's Right Energy Systems Technology, something like that. So there's 2 supercaps in parallel here. Why supercaps? Well, they've got incredible longevity. We're talking 100,000 cycles. Your grandchildren will be using them. Very, very safe. There's not a lot of combustibles in a supercap. And also they've got a really high efficiency for charge and discharge, and they can be shipped completely discharged. That's kind of nice. Just behind it, in fact, maybe behind me is a better spot to look, is unfortunately a product that's no longer in the market. And what you're looking at down here is, if I can get to it, is a Redflow battery. This is the Redflow Gen 2 or 3. I'm just trying to remember what generation it was, but unfortunately the company folded. What is Redflow? Well, it's a zinc bromine flow battery. That's right, flow means it's got pumps that circulate the zinc bromine solution across some carbon plates, and it deposits the zinc onto the carbon plates when it's charging and then removes it when it's discharging. So it's basically a zinc carbon battery that lasts forever. And when I say lasts forever, well, basically it's a cradle-to-cradle product. It means every part of it can be replaced, and the zinc bromine solution isn't consumed. It really just gets a little bit of contamination from the carbon, and as a result, it needs to be cleaned. So I think the process would be pumping through a filter to clean it. So yeah, this is the Redflow battery, and the capacity is 10 kilowatt hours and about 3 kilowatts of peak power. I must admit they were a fairly complicated product to not just install but to configure. There's a lot of comms and control required for these, because one of the characteristics of a flow battery is it actually needs to completely discharge itself periodically. About every 96 hours or so, I think, is an optimum. And so it goes through what's called a stripping cycle, where it discharges all its energy until it's cleaned the plates of all the zinc to stop the growth of dendrites, little sort of pyramids that start to build up in one spot. As a result of that, if you've got one, it's going to be offline every 4 days or so for maybe 10 or 12 hours. You can schedule that. And in fact, the software tries to schedule it for you. But if you've got 2, they alternate. And the more you have, it's a bit like a RAID array, the more redundancy you have. But it's a sad story. Don't think anyone bought the company or the technology. So another great Australian idea and product that is no more. So yeah, it's a bit of a museum, isn't it? Now I'm going to take you somewhere where it's a little bit noisy, and I can't do anything about it, but let's just give it a go. This is one of our most recent additions, is a big battery. Yeah, big. Not 40 kilowatt hours, not 100 kilowatt hours. How does 800 kilowatt hours strike you? Yeah, that's our big battery. Those are Pylon Tech power cubes, and this is only about a little under half of all the batteries we've got. So it's all we could fit in this building, and we're actually building multiple systems with these. So it's a big project. But the thing that's making the noise right down the end there is something I'm really, really excited about, is the Solus 50 kilowatt hybrid inverter. It just does everything I could imagine I'd want an inverter to do as a bit of a fiddler. I'd like to change programming settings. I can do it from an app. I can do it from the front screen. I can do it from my laptop in my office anywhere in the world. So that's really nice. And the amount of data it gives you too. You can really monitor the system, but it is rather noisy because it's working hard. It's got a huge 100% overload capacity for solar, well, overclocking as people like to call it, the DC-AC ratio. So even though it's a 50 kilowatt inverter, 100 kilowatts of solar would be just sweet on this. We only managed to get 68 kilowatts of solar onto it, so really not huge. This room has got a few other systems that we've been doing some testing on. This is the Anker Solix X1. I reckon I'd probably vote this as one of the most attractive looking residential systems out there. If looks are the primary, I reckon this one wins. I like the subdued metallic grey colour. It's all metal. In fact, it's C5 corrosion resistant, so it can go quite close to the ocean if you happen to be lucky enough to live in that sort of location. And it's comes in two versions, one with MPPTs, so it's DC coupled, and one which is AC coupled. So this is the AC coupled one just down here. There it is. Okay. The little screen on the front here, I just love the way it just lights up as you approach and tells you state of charge, amount of power coming from the grid to the grid, what the loads are drawing, all of that. And down here, I'm sure you probably haven't heard of this company, but they're new. It's a Melbourne-based company called Green ESS, and we're testing this. I don't know if it's actually available yet, but it's got some unique features. Yes, it's an inverter and a battery in a box. Yes, it's got nice little lights on the front, but why has it got all these little? What are these little things here? These little pigeonholes. What are these little pigeonholes for here? Well, this is a little charging bay for products for their other batteries for their other products. So this is a lithium-ion battery, and so you can have up to 12 of these charging bays in here. And this battery works with a range of their other products. We've got the e-bike, the e-scooter. I've seen the e-golf cart. They've got line cutters, or whippersnippers as we call them in Australia, chainsaws, leaf blowers, even power tools. And so in a way, this is your charging station. And there's even a docking unit for this to turn it into the biggest power bank you've ever carried on your backpack. So pretty cool, Green ESS. Expect to hear more about them. And over here is where stuff that we've recently taken off test and going to redeploy. So we redeploy a lot of the stuff that we've already used for testing. We don't just kind of throw it away or store it and forget about it. We try and use it. And so here on the co-op, there's 30 homes, and we've been progressively distributing some of these systems around those homes so that they continue to be useful, generating renewable energy and storing it. So yeah, nothing goes to waste if possible. All right, well, I'm going to take you to look at the former charging area, well, not charging area, the former solar input for our battery systems, our microgrid systems. Now, when I say former, is they're still on the wall, but what we got here is 4 20 kilowatt three-phase Select Sun inverters, and these were sold in Australia through Selectronic, and they were AC coupled to the Selectronic power chain system that I showed you earlier. So they're currently offline because we wanted to test the Solus 50 kilowatt hybrid inverter, and we needed some solar. So we had to grab the 4 strings that were coming in here and put them onto the Solus inverter. So even though they're off, they may well come back on again because we love them. And they've got some really great control features. So for managed AC coupling that Electronic do. These were brilliant. Way down here, and you might assume there's some EV chargers. Well, in fact, there's 8 charging points for cars that using an AC supply, so 3-phase AC outlet it basically is what these are. So that means they can charge cars which have the capacity up to about 22 kilowatts, though most cars are way below that. Here is some more batteries. Let me just swing around so you can see it a bit better. So this is I've got to turn the camera for you. So this is a Solentech 20 kilowatt hybrid inverter. Look at the size of this thing. It's smaller than some 5 kilowatt inverters. It's heavy though, so there's obviously some grunt in there. And it's 20 kilowatts output, which is actually perfect for what we want it for, which is to provide an alternative stored system for EV charging. Now, one of the things about a microgrid like ours, which is not connected to the utility grid, is we really do have to watch our energy use sometimes. And at night time, we'd prefer to minimize the amount of big loads that could be scheduled. But sometimes you just need to charge your car, right? You're not going to wait till the sun comes up. You've got to go to work. So this system has got connected to it the Force H1 Pylon Tech high voltage battery stacks. So we've got, I can't remember exactly, I think about 15 kilowatt hours here of stored energy. So you can do a little bit of a top up of your car and it will just come out of this independent system, which is parallel with the microgrid as well. So kind of both work. Right, well, I'm gonna have to walk a little bit further now. Sorry about the bright sunlight glinting across me all the time, but we celebrate the sun. It's where all our power comes from. You'll see quite a few electric cars around here. Since this charging station's been built with the 8 EVSEs, we've got now 6 electric vehicles out of 30 homes here at the Smart Energy Lab. Well, I should say here at Murumuru Co-op. Oh, I just spun you around so you can see where you're going. So I'm going to show you 3 systems actually. Now I probably should back up a little bit so you can see what's behind me. So this is my neighbour's house. I've got great neighbours. They let me put systems on their houses for test purposes. Of course, they get the benefit of the power and the storage. So this is my neighbour's house, and I don't think anyone's home at the moment because their car's out, so that's okay. So we've put a range of systems on here. One of the first ones was this Solar Edge solar inverter. Now, if you haven't heard of Solar Edge, it's an Israeli company with a global presence. They've been in Australia for over a decade, and they have a kind of special feature. This is a inverter that does power conversion from DC to AC, but the maximum power point tracking primarily happens up on the roof, on the back of every solar module, using optimizers. Yeah, these are little DC-DC converters, sort of about the size of a cigarette packet, that the solar panels connect into, and the output of each of those goes onto the string. That means that this inverter has module-level power electronics, MLPE, module-level monitoring, and module-level safety. It can actually shut down the whole roof to just the highest voltage as one panel. So safety is another big plus. Of course, they've got an amazing monitoring platform, and if you're an installer, you get to look at every single panel. It's incredible. You can see every single panel up close. So next to it is a product called eStore. Don't actually know much about this. From memory, this just turned up at the lab one day, and I don't think we had much explanation about what they wanted, so we just installed it, and it's been filmed a few times now. Inside this cover is a GoodWe 2.5 kilowatt. It's the EM series hybrid inverter, and down the bottom here is a 10 kilowatt hour Alpha ESS battery module. So the two have been sort of bundled together with some isolation and control equipment behind here, and listed as a complete all-in-one system. So there you go, the sort of DIY all-in-one. Now, SolarX. SolarX have been, I think I've had every generation of their inverter through the lab. And for a company that's been in the Australian market for about 10 years now, they've learned a lot. And they've learned a lot about our standards now, compliance requirements. So I'm really pleased to see that improvement. They also make battery systems. We'll partner here with Triple Power. So down here is a stack of 25 kilowatt hours, a pretty small footprint again. These small footprint stackable systems are great for garages and areas where you don't have much floor area. So coming back to the inverter, this is a 10 kilowatt three-phase hybrid inverter. So it's got a bit of grunt and it's got 4 MPPTs, which is really great because we've got 3 different orientations on the roof. So we needed at least 3, so it's got a spare one there. So you can put a lot of solar on this with a high DC to AC ratio. Can't remember off the top of my head what it is. All right, now let's keep going. I'm going to swing you around. So what you're looking at here is our little solar trailer. It's a training trailer. It's got a bunch of systems in it that we've used for students to train on. And if I take the lock out, open it up. Okay, so there we are. It's a Victron-based system, and as you can see, it's got the multi-grid battery inverter. It's got the blue solar MPPT, and it's got a DC-DC converter to create 12 volts from the 48-volt battery, and one of these wonderful color controllers. There it is there. And all of this is cloud connected, so it's got comms, a little antenna. So that is the geeky side of it. But around this way, we've got our kind of end user area. So the idea of this is it's a little trailer that we can park anywhere on the property and provide localized power. It's been used for music festivals and other conferences, etc., where we've had a lot of people camping. So we just put this out in the paddock. So it's got a fridge, it's got a little pie warmer, it's got about 10 AC outputs for people to plug their devices into to charge them. It's got lights and it's got internet. So there you go. It's a little mobile power station. Pretty cool. Whoops. Sorry, got a little problem here. So I'm going to show you a few more. That's how we're going. I can talk forever, but I've got to walk a bit now. So I'm taking you down to my house to have a look at probably one of the most exciting systems on the Australian market, if not globally at the moment. I wonder if you can guess who that might be. Well, here's the big reveal. Ta-da! Yeah, it's SIG Energy. No surprises there. You've probably seen a lot of videos with me standing in front of this equipment or similar. Yeah, amazing product. In fact, our one's got the 25 kilowatt fast DC charger for our electric vehicle, which is really cool. This is a 10 kilowatt inverter, hybrid inverter on top here, and we've got 4 times 8 kilowatt hour batteries, so it's a total of 32 kilowatt hours. There's the gateway, which you can probably just hear a little bit of a hum. So this does the exchange with the grid, so it controls when the grid fails, can island the house instantaneously. 0 millisecond crossover, which is pretty amazing. But one of the great things about this design is its modularity. So you can have like a 5 kilowatt inverter and a 5 kilowatt hour battery, and you can go up to megawatt hours with full stacks and multiple full stacks all working in parallel. I personally have visited a site in South Africa where they had 4.2 megawatt hours of these, 96 of them, giving them 2.1 megawatts of AC power. and it was running a huge cable factory. And that cable factory could not have a millisecond of power interruption. And this system, they tested it, could perform. They just flicked the main switch, and the factory, with all the hundreds of workers and all the cable run through all the machines, just ticked over perfectly. So there you go. Now I might have to switch cameras at this point because we've got to go somewhere to see the next thing. So let me just get myself organised here. Guess what's going to happen? I'm going to have to put you in my pocket and switch cameras. Oh, where are we? Yeah. So I'm going to have to put you in my pocket and switch cameras, and yeah, because you'll see it'll be too dangerous for me to hold this otherwise. All right. So electric everything is our motto. Got the electric scooter, which I love. I mean, this property's like 2 kilometres long, so getting around here can take a while, but we've got quite a good road system, so that really helps. I think I'm being followed by a lawnmower. Today is one of those beautiful, well, it's still technically winter, isn't it? So yeah, not quite spring, but one of those beautiful winter days here in Melbourne. And we're atop Mount Toolbox, which is about an hour and a quarter out of Melbourne. Oh my God, here he comes. Well, this is actually what I came to show you, is our little solar farm. So this powers our microgrid, which has at the moment 7 homes, 8 EVSEs, 2 DC fast chargers, a 20-bed accommodation unit, and a classroom, as well as a lot of hot water services and a commercial kitchen. So yeah, all of that is on the microgrid. And so we've got 2 arrays here. You're looking at just the front, the 2P, which means 2 panels in portrait, and behind it, if you kind of scroll this way a bit more, is the 1P. So the 1P is 1 panel in landscape format. So way down there somewhere. They're pretty long, aren't they? The 1Ps are 90 metre long, and the 2Ps are 45 metres long. Now, there's something I'd like to share about how this tracking system works. And I should point out this is a tracking system, so that's being quite early. That they're tilted towards the east quite predominantly. So that was probably a bit of a giveaway then, but anyway, that's what they call an Easter egg. I won't say what that was. And they have a weather station that controls them. So if I turn around, you'll see behind me, this weather station measures wind speed and direction, and it's got a transmitter on top, and the transmitter transmits to all of the trackers in the solar field, and you could have literally thousands of them. They all controlled wirelessly, all the motors. So they don't have to run lots of comms cables. They use long-range wireless, I believe, so you can get through where others won't. Now, if I show you the back of these things, this is actually a test system for Longi. Longi provided the panels, and Arctech Solar used this as a demonstration and training facility. So Arctech Solar supplied the trackers, and it's actually tracking just then. I don't know if you heard it, but if I walk along here a bit, I want to show you something interesting about the panels. All right, so I'm at the midpoint of this tracker, and you might notice that there's something kind of weird going on here. Why is this panel white at the back, and this panel over here, it looks like it's the wrong way around? It's because the second one is a bifacial solar module. So it actually has no backsheet, and it can collect solar energy from the front face or the back face. Now, why would you want to do that? Well, here I'm standing in what you would say is the shade, right? I'm standing in the shade, but the shade is not zero energy. There's about 20% of the global solar energy hitting any one spot is coming from blue sky. It's not actually coming from the sun. It's coming from reflected light, not just sky, but also off the ground. It's what we call albedo. There's reflected light from the earth. And depending on the color of the ground, albedo can be significant. Here, it's green grass mostly, and so it's only about 8% albedo compared to global. But if you've got light-colored soils, or if you're in the snow, it's insanely high. So that's actually free renewable energy. Isn't that cool? You're getting it for free because it's just there without having to buy a bigger panel. So somehow your panel that you might have thought, I think these were 435 watt models, you might have thought they were 435 watts, but actually they're more because of that bifaciality. So that's, and I think you can now see the 1Ps behind me. There they go. That's the 1Ps. Fun fact, we installed this during COVID lockdown, so everyone kept 1.5 meters apart, and it was pretty challenging. But we did have a lot of volunteers come and help put the panels on. In fact, a large crew from Power Plus Energy came for like a social/training day here and put the panels on. So that was really nice of them. Now, another thing you might have glimpsed when I was walking is this. People say, "Oh, Glenn, what is that thing? Is it a sculpture?" Well, actually, it's a wind turbine from yesteryear, known as Darius rotor. So Darius rotor is a technology where the wind doesn't start turning the blades. You kind of think, well, hang on, that's pretty dud. Well, yes and no. The idea is that once it starts rotating, so it's got a starter motor, wind turbine with a starter motor sounds fun, and when it starts rotating, the airfoils get lift, and then they will continue that rotation. So it did work, maybe 40-something years ago a few times, but it turned out to be a net energy user. So what do you mean net energy user? Well, the problem was the starter motor. It actually used more energy starting it up because of our intermittent wind. So, you know, the wind would gust, the anemometer would say, it's windy, let's get going. The big 11 kilowatt electric motor would crank up to spin up this big, heavy thing, and then the wind would die down. So the intermittency was a huge problem. Now I'm going to have to jump back on a little scooter and switch cameras. All right, here we go, switching. Next on the Magical Mystery Tour is our solar panel testing site. And it's actually owned by a company called P-Vision. They commissioned us to build it and locate it here. So it's their product, and they do proprietary testing, i.e. for the manufacturers. And why all the way over here near Melbourne in Australia? Well, actually they have multiple sites around the world. So I guess we're their Australian cool climate location. So let me pull up here and show you it. Okay, so switching cameras. I always seem to have the sun in my eyes. Okay, so on these racks, each rack has about 8 or 9 panels, being a string. The panels under test. So currently we've got, I think, about 4 different systems being tested. The capacity is 10, so we've got quite a few racks yet to be filled up here. So companies will send their product and we'll mount them and connect them into an inverter in a shed. I'll show you that in a second. And all of this is monitored with a lot of sensors. So they've got the full atmospherics, the meteorological values, wind speed, direction, temperature, relative humidity, ambient. They've also got cell temperature, and then they've got lots of irradiance measurement tools. They've got them at the tilt angle of the panel. They've got them for global, horizontally. They've got them for albedo on the rear. Yeah, and all of that is being stored and recorded and analysed. And so we're just the host for all this, but I must admit it's pretty impressive. And by the way, all the racking that you can see behind me is supplied by Clenergy. So big thanks to Clenergy. So we've got the Solar Terrace 2 and 3 from memory. So one which is post into the ground, and the other one which is with concrete supports. So we just put in big pads. Putting in a ground mount system has become so easy. Like, it used to be a big deal. You basically had to be a builder and constructing a fence with features. But these are so well engineered. It's Lego. These were done by drilling with a auger, a pilot hole, then wet cement mix went in, let the posts level them, let them harden, and then just assemble. Piece of cake. Yeah. So over here, what do you know? More solar panels, but actually different project. So this was a project for one-stop warehouse, now called OSW, and they supplied these Tongwei, known in Australia as TW Solar, modules. TW Solar, I've actually been right through their facilities. I've been to their solar panel plant, which is just absolutely state-of-the-art, amazing. There's hardly a person in there. It's just robots zigging around, and you walk down a glass corridor so you can look at it all, but you can't interact. It's clean room stuff. I've been to their cell factory, which is equally amazing, and I've been to their where they make the actual polycrystalline. So that is kind of like an oil refinery in scale. They're huge industrial plants, but what they make, Tongwei makes something like 29% of the world's polysilicon. That's pretty amazing. So in chips and from computers and solar panels. So Tongwei, which is a 40-year-old Chinese company, they weren't making solar panels 40 years ago, but they've been making them for a long time, now does the full suite. They make the silicon, they make the cells, they make the wafers, they make the modules, they put them in their cardboard box and ship them to you. So vertical integration means one big thing: cost saving. There's not lots of middlemen and women to clip that ticket. It's just manufacturer, distributor. It's a really sweet arrangement. So I like to think of this, you're getting tier 1 panels for tier 3 pricing because of that cost advantage in being vertically integrated. Yeah, so expect to see a lot more of TW Solar. Now, the good people at OSW also supplied this Sol Planet inverter. So this is a 3-phase solar inverter. So I think it's the 8 kilowatt model. Sol Planet actually is one of the older Chinese inverter companies. They've been in Australia for a long time, and they make really excellent products. The aesthetics of this too, I'm kind of getting a bit tired of just your beige, white, milky, creamy, whatever boxes on the wall. Look at this one. It's a beautiful pale blue, like the sky. Yeah. So, and it sort of floats, the way the design is with the dark colours behind. So, designers now, or engineers who build these things, need designers to help them understand the aesthetics as well. Okay, another one. What are we going to do now? Just turn you around. We're going into this shipping container. There's a lot of shipping containers here. I love them. it's really hard with one hand. There we go. Well, probably can't see much. I don't know what the light isn't like in here, but look at that. What do you know? More batteries. So this actually is another project using the Pylon Tech power cubes. So there's about 400 kilowatt hours of power cubes here in, what are we in? I think you go up to 900 volts, but I think we're going to have to reduce it to 750 because we're changing inverters. We were going to be using the 250 kVA Cynic cell, which is an excellent product, 4777 Part 2 certified even, though this is going to be an off-grid. So it's a hybrid inverter, basically battery and AC. But we decided to switch to smaller 30 kVA Cynic cells and put one on each battery bank. It means that we can do some interesting things with testing. So these battery modules are functional, but they're also used for a little bit of testing to see variation in cell voltages, etc. So we've got a lot of monitoring for these too. We've also got the Huawei 30 kilowatt. I think it was pitched in Australia as the 29.9 for the silly reasons of the rules in terms of secondary protection requirements. But actually, I believe it's a 50 kilowatt. It's just detuned for the Australian market. It's got 8 inputs, 4 MPPTs, and it's currently being used to convert the DC energy from the testing sites to AC power, and then in the data cabinet below is all the fancy monitoring equipment from P-Vision. So there you go. That's the shipping container system. Now this system will kind of work in a strange way. What we're going to do is try and fully discharge the batteries every night after the sun's gone down. So you might ask, why, Glenn? Why would you do that? Well, the purpose of this system is actually to test solar panels. And to test the solar panel, you need them to produce as much yield as they can with the available sunlight. So because they're monitoring the solar radiation and they're also monitoring the output of the panels, if there's any curtailment, because on an island microgrid, when the microgrid system's full, we've got to stop the generation out there, and so we use frequency shift power control, and there's also some comms based as well. And so we basically shut down or derate a lot of the inverters, which means that these panels wouldn't be producing their full power with the given sun, and so it's a bit of a problem. So the plan is this shipping container system with 400 kilowatt hours of storage will be enough to capture one day's generation from the test site, and then we'll be able to discharge the battery at night time into useful loads, and even some questionable ones, like just heat empty rooms in the lodge, just because we've got the power. Then the next day the batteries are empty and ready to go. So that's the plan. I think I'm going to take you back to the studio now. So I'm going to switch cameras and jump on my scooter. So here we go. Well, I was lucky with the weather today. We've had some pretty poor weather lately, and trying to do this show around for you would have been a bit difficult. But anyway, the weather behaved itself. So here we are, coming back into Smart Energy Lab land. See my neighbours down there holding hands, very sweet. And whoa, the parking zone. Okay. Time to switch back to my other camera.
Got full charge yet?
Okay, let's go back to the studio. I didn't show you our other big beastie. This is a 50 kilowatt DC fast charger from Delta, but it's an older one. So it's quite old. It would have been probably one of the first ones in Australia, actually. And look at the size of this thing. It weighed 680 kilos. It is 50 kilowatts, but most of that weight is a huge transformer in the bottom. Almost half of that enclosure is one transformer. Whereas my Sig Energy 25 kilowatt charger is, I can lift it by myself. It's part of that stack. So yeah, power electronics can come a long way. Cool. But anyway, this is doing great service, so we still love it. Thank you, Delta. Okay, in we go. Back to the studio. So I hope that's been of some interest to you, and not just me showing you all the insane amount of equipment that we have here at the Smart Energy Lab. But I think that's a bit of a first for me to try and do a show like that with walking around and talking continuously and switching cameras. So there we go. Wow. The sun's starting to click through a little crack in my window. So just to wind up, everyone, thanks very much for watching another Toolbox Tech Talk. See if I can grab that DJ Glemmo sometime and get him to get back into the seat here and do his silly stuff. Yeah, because we miss the gold chains. So let's hope he comes back soon. Anyway, till next week, thanks for watching. Check it.